Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the critical world of watchdog timers in embedded systems. It's a topic that's often overlooked, but as we'll see, it's absolutely crucial for reliable operation. Let's get started.
I'm eager to hear this. The reliability of embedded systems is paramount, especially in safety-critical applications. What are some of the key takeaways from this article?
Absolutely. The article highlights the importance of robust watchdog timers, not just as a last resort, but as an integral part of system design. It uses the Clementine spacecraft mission failure as a stark example. A simple software timeout failed, leading to fuel depletion and mission failure, all because the built-in watchdog timer wasn't used. Crazy, right?
Incredible! So the article emphasizes proactive rather than reactive use of WDTs?
Precisely. The author argues that WDTs should be used proactively, not just as a last-ditch effort. He points out that many systems experience numerous minor failures that are handled gracefully, but a more serious failure could easily go undetected without a reliable WDT. Think of it as insurance. You hope you never need it, but you're glad you have it when things go wrong.
That makes perfect sense. But what constitutes a really great WDT? The article mentions several types, internal and external. What's the difference?
That's a great question. The article strongly advocates for external WDTs, especially in safety-critical applications. Internal WDTs, while convenient, are often too easily bypassed by rogue code. They often share resources with the main processor, making them vulnerable to the same failures they're supposed to protect against. External WDTs, on the other hand, offer much greater independence and robustness.
So an external WDT is like having a separate, independent safety net? What about the design considerations for these external WDTs?
Exactly. The article delves into the characteristics of a great WDT. It should be independent of the main system clock. It should initiate a complete system reset, not just a CPU reset. And it should ideally provide some form of debugging information when it triggers. The author even suggests using a separate microcontroller, like a PIC or MSP430, as the watchdog, ensuring complete isolation.
Wow, that's a level of redundancy I hadn't considered. The article also discusses different watchdog timer implementations, like windowed watchdogs. What's the advantage there?
Windowed watchdogs are a clever approach. Instead of simply checking for a periodic kick, they require the watchdog to be tickled within a specific time window. This makes it much harder for errant code to accidentally or intentionally disable the watchdog. It's a more sophisticated approach that significantly reduces the chances of false negatives.
I see. So it's not just about the frequency of the kick, but also the timing precision. The article also touches upon watchdog timers in multitasking systems. How does that add another layer of complexity?
In multitasking systems, the challenge is ensuring that the watchdog monitors the health of all tasks, not just the one responsible for kicking the dog. The article proposes a sophisticated approach using a watchdog task that monitors the execution counts of all other tasks. It's a more comprehensive approach that ensures no single task failure can go undetected.
That's fascinating. It sounds like a significant amount of overhead, though. Is it always worth the effort?
The author makes a compelling case that the cost of a failure often far outweighs the cost of implementing a robust WDT. In safety-critical applications, the cost of a failure can be catastrophic, making a robust WDT a necessity. Even in less critical applications, the cost of customer dissatisfaction and potential product recalls can be substantial. A well-designed WDT is an investment in reliability and peace of mind.
Absolutely. The article concludes with a cautionary tale about a kitchen hood fan that required a manual reset. A seemingly simple device, yet prone to failure. It underscores the point that even simple embedded systems can benefit from a well-designed watchdog.
Exactly. The hood fan example perfectly illustrates the author's point. Crummy firmware is unacceptable, regardless of the application. It's a reminder that even in seemingly simple devices, a robust watchdog timer can prevent frustrating failures and protect against potential hazards. We need to move beyond the "it's just a glitch" mentality and embrace a more proactive approach to system reliability.
Well said. This has been a really insightful discussion. Thank you for shedding light on this often overlooked aspect of embedded systems design. It's clear that a well-designed watchdog timer is not just a nice-to-have, but a critical component for building reliable and safe embedded systems.
My pleasure. And thank you to our listeners for tuning in to Tech Bytes and News. Remember to subscribe for more insightful discussions on the latest in technology. Have a great day, and we'll catch you next time.
Bye-bye.